Now in this lesson we're going to look at how we solve radical equations. To do that, we're going to first identify radical equations, and then we're going to examine the steps that we follow in solving radical equations. So a radical equation is just an equation that has one of its variables as a radical. This is a radical. Radical consists of a square root sign and a number under the square root sign, which we call the radicand, which is spelled radicand, R-A-D-I-C-A-N-D, radicand. And so these are some good examples of radical equations. Now, what we're going to do to solve radical equations is the first thing we're going to do is to isolate the radical expression. And all that means is that if you have a radical on the same side as a non-radical, just get rid of the non-radical from that side. So we will follow the first step. So we subtract 2 here and we subtract 2 here. Then we have square root of x is equal to 4. Now we're going to remove the radical. So because this is a square root, we're going to square both sides to get rid of the radical. And so we see here that x is equal to 16. Let's look at another example here. So here, in this case, the first thing we want to do is to try to see if we can isolate the radical expression. Here, the radical expression is already isolated. So we have square root. So we're going to square both sides. So x minus 1 equal to 9. We add 1 to both sides, and we see that x is equal to 10. Let's look at the next example. So the radical is isolated, so we're going to square both sides. So this is going to give us x minus 1 equal to x minus 7 squared. So x minus 1 is equal to, so x minus 7 squared, let's use some space here for our work, x minus 7, x minus 7, we can FOIL it, so we got x squared minus 7x minus 7x plus 49. So this is going to give us x squared minus 14x plus 49. So let's group common terms. So we have x squared minus 14x minus x plus 49 plus 1 equal to 0. So we have x squared minus 15x plus 50 equal to 0. So here, when we factor, if you need some help factoring, there's a lesson that focuses on this exclusively. So we have x minus 10, x minus 5. So what we now have is x minus 10 equal to 0, or x minus 5 equal to 0. So we add 10 to both sides. So x equal to 10, or we had 5 to both sides, x equal to 5. So these are possibilities. So it says check your answers. So what we're going to do is we're going to try to plug this answer back in there under the square root sign, replace x. So we see here 10 minus 1 is 9, is positive, so we can get valid square root from that. And then we have a 5 here. 5 minus 1 is 4, is positive, so we can expect to get a good square root from that. Now let's look at this example here. We're going to isolate this, which is already done for us, so we're just going to square it. So we have 9x squared plus 4 equal to, so let's distribute this. Let's do that here. 3x plus 2, 3x plus 2. So we have 9x squared plus 6x plus 6x plus 4. So this is 9x squared plus 12x, well, plus 6x plus 6x plus 4, which is 9x squared plus 4 is going to give us 9x squared plus 12x plus 4. So now let's go ahead and group common terms. So we have 9x squared minus 9x squared plus 12x plus 4 minus 4 equal to 0. So this is going to cross out. This is going to cross out. So 12x equal to 0. Divide by 12. So x is equal to 0. Let's plug it back in. 0 plus 4 square root of 4 is 2, so we can get a reasonable value here. So this is just how you deal with radical equations. Let's just quickly summarize. The first thing you want to do is to isolate the radical expression. The next thing is to remove the radical, and that could be done by squaring both sides or cubing both sides depending on what scenario or situation you find yourself. Then solve for the equation that is created, and after that try to plug in your results. The reason why you do that is if you end up with a situation where your x becomes your value of x leads you to have a negative number under the square root sign, we have to reject that because that puts us in a realm of imaginary numbers, which is not really the focus of this